Alright, this is lesson 1.2, properties of real numbers. We're going to classify real numbers and use the properties of real numbers to evaluate the expression. So there's going to be a lot of different categories here. There's a couple of fun videos you can watch. This one doesn't specify these different categories, but it's fun. There's another one listed on my website under resources that you can watch that's a fun song that will get stuck in your head and help you. So let's start with complex numbers. These are all under the complex number system. And complex numbers are a combination of real and imaginary added together. So 1 plus I, and that I stands for an imaginary number. I is really the square root of negative 1. And that square root of a negative is what gets us into that imaginary category. Then if we get a little more specific into real numbers include all of these below: rational, integers, whole, natural, and irrational. So it would be positive numbers, it would be negative numbers, it would be whole numbers, decimals, all included in real numbers. Irrational numbers are numbers that go on forever, randomly, don't repeat, and they just go on and on and on, dot, dot, dot. Keep going. Rational numbers are either going to repeat or stop. And you could have fractions, but as if you see, the fraction would be 0.5, so that decimal does stop. Integers are negative numbers, 0, and positive numbers. Whole numbers are just 0 and the positive numbers, and natural numbers are just your positives. So I always kind of think of it as you're growing. You start in your natural, when you're born, you learn 1, 2, 3 to count. Then you learn what 0 is, so then we move into the whole numbers, 0, and you still know 1, 2, 3, 4. Then you learn about negative numbers, so integers. Then you learn about fractions, and so on. So it kind of builds on itself as you grow. So let's go ahead and look at what each of these sets involves, and we kind of talked about it above. So real, most of the numbers we're going to deal with in the beginning here are real, so they're going to include all of those sets: irrational, rational, integer, whole, and natural. So all the ones below here. So I'm just going to use the symbols, and we'll learn that I symbol. Kind of a double I there, and the Q and the Z and the W and the N. So it's just going to include all of these below. So some examples would be -1, 0, 1/2, 2, kind of the ones we listed above. Irrational is going to be an I, and those are square root of a non-perfect number. So square root of 3, or 0.34876 going on. Rational would be our fraction, our a over b, and b cannot be 0 because you can't divide by 0. So some examples: 3/4. Rational. Integers are those negatives, 0, and those positives. So -4 is an integer. Whole represented with the W. I can't really draw the double line that you normally see like on the other. I guess that kind of works. There we go. Whole numbers are just 0, 1, 2, 3, and so on. And 5 or 0 would be an example. Natural numbers, again, are the ones when you're just learning how to count. So 8, giving a specific example. So let's go ahead and just categorize what set these numbers are in. So looking at -29, is a real number. It's not imaginary. It is an integer because it's negative. Abbreviate. And then it's also rational. Okay, square root of 51 is a non-perfect number. So when we do the square root of a non-perfect number, that was irrational. And it would also be real. Negative 4 over 9, well, we can see that it's a fraction, so we know that it's a rational number. And it's also real if it's rational. Square root of 25 is 5, so really this reduces to negative 5. So it's going to fall into a couple more categories here because it is the square root of a perfect number. So it is an integer, negative, it is real, and it is rational. Try that next one on your own, 0. If you need to, look at the box above and then write all of the sets it belongs to. And double check your answer when you're ready. And if you wanted to, you could have W, Z, R, and Q if you just wanted to use the letters right here that we had the letter that represents that set. That's fine too. 9/2 cannot be simplified to a whole number, so it is just rational and real because it would be negative 4.5. That decimal does stop. All right, let's talk about the different properties, and that's where that song that will get stuck in your head if you watch that video, but that could be a good thing. So commutative is going to commute or move. So notice how the A and the B are switching places. Associative is grouping, to associate with a different group. A and B, friends over here, but now B and C are friends over here, so regrouping. Identity is just keeping its identity, staying the same. So either adding 0 or multiplying by 1, it's still staying the same. Inverse is the opposite or the reciprocal. Opposite or the reciprocal. And reciprocal is when you flip that fraction. So there's where it's being flipped, multiplied by its reciprocal. Closure property, I don't have a real fun name for that one. It's just basically if you add two real numbers, you're going to get a real number as the answer. Same thing if you multiply them. Multiply two real numbers, you're going to get a real number as your answer. And distribute we've seen before, it's just handing out. Giving it to both. So let's take a look at a couple examples down here. Now they might trick you with some parentheses, so make sure to look at those carefully. So what's happening here? It's first that our 4 and our 13 are being grouped, and now our 5 and our 4 is being grouped. So we're regrouping. So if we look up here to see when the groups change, that's associating or regrouping. So it's associative, and I'm just going to abbreviate, of, and we're using multiplication. So I'm going to abbreviate, associative of multiplication. Next, number 2, it looks like we are taking that 2 and we're getting 2x, so they're multiplying there, and they're getting 6 by taking 2 times 3. So when we take and hand this 2 out to each, that's when we distribute. I think most of you are pretty good at getting that one. And there's no separation because there's both multiplication and addition sign in there. Next, if you want to try any of these on your own, you can pause and check at any time. So looking at the parentheses here, we're not changing groups. These are the same groups. But it looks like we have 11, 9, and 10, and now I have 9, 10, 11. It looks like our order's changing. So when we are moving things around, that is the commutative. Commute, like you're commuting to work. Might hear on the news. So it's the commutative property of addition. Lastly, negative 5 times 1 is still negative 5, so how is it keeping its identity? The identity property of multiplication. All right. Next, we are going to find the additive and multiplicative inverse. So additive, meaning adding, what will we add to that for it to be opposite? Well, opposite would be 5/8. Next, multiplication is our reciprocal, and that's when we flip. So we are going to flip that, and it becomes 8/5, negative 8/5. Okay, next is 8 positive, so it would be negative 8 for its opposite, the additive inverse. And then for its multiplicative inverse, we would flip it. So 8 is going to go in the bottom, and what holds the place up here? There's an invisible 1 under there, so it'd be 1/8. All right, on the next one, it'd be nice to change that to a fraction. So what we could think about is that being 1 1/4. And what we do is take the denominator, multiply it by our whole number here to get 4, and add our numerator. So it's 5/4. So now we are going to opposite and flip it for its reciprocal. Try that last one on your own. So remember, we're going to multiply those two together, the denominator and the whole number, and then we're going to add that numerator to it. And you're going to keep the same denominator. So change that into an improper fraction. And you should get 2 times 2 is 4, plus 1 is 5/2. You could also type that into your calculator. I showed you the fraction button in the last video. Type in 2 1/2 and then hit the math and then enter, and it will change it to a fraction for you. So opposite would be either negative 5/2 or negative 2 1/2. And then its reciprocal is now pretty easy to just flip to get 2/5. All right, let's look at a real world example here. So we've got two different methods. The first method is to multiply then add. So what we're going to do is take 6% of each of these and then we'll add it together. So 359.95 times 0.06. Why 0.06? Well, 6%, we have to change that to a decimal. So 6%, I move the decimal place 2 places to the left, and it's 0.06 that I'm actually multiplying by. So working our way through to 19.99 times 0.06, and so forth. So again, this first one we're going to multiply and then we'll add. And going through and doing that, you'd get 21.597 plus 13.1994 plus 4.74 plus 8.97 plus 5.94, and then you'd add all those up together and you get 54.95. Sorry, 45. So that is your sales tax. Method 2, in my mind, is a lot easier. You're just going to add all these up and then multiply. And that's how they do it on a receipt, if you'd notice. So adding all those up, you would get, nope, I guess I didn't give myself an answer. Oh yeah, $907.44, times it by 0.06, and then you would get, oh, imagine that, $54.45 for your tax.